So you can see my screen, right?
Yeah.
Okay. Okay. So today I will start with a new project. As usual, I will consider a space model and I will put some name. Okay. And as usual, in the location we are going to save so that all the subfiles also it will save under that particular folder. Okay. So meter kilonewton as usual. Next. So today I will continue with the structure wizard. So I will finish. We have seen structure wizard examples before also, right? Many times. Okay, so what we will do means like today we are going to consider steel structure. So for that, like we can consider any one of these truss models. Okay, what I will do means like I will take. So here it is different. Here it is different. That's what the thing. Okay. Okay. So I will consider this truss. Okay, and I am going to continue with the available lens height, width, and all. Okay, if we want, we can change that. You know now how to change and all. See, the total length is 50, height is 10, and width is 10 here. So we have only one base. That's why here only one. But we have three now. That's why here we have in length it was three. If what if we are putting four? See here accordingly it's getting changed. Okay. Okay, I will continue with 50 and I can consider height of 8. So little changes I have made. So I am taking height of 8 and then length of 50 and then number of base along length is 4 so that we have more here. If we are putting 3, like it's getting reduced. Okay, so okay, I will continue with the 3 itself. Okay, and I'm going to close it and we can transfer or merge the model with STAAD Pro 0, comma 0, comma 0. Okay, so as usual, go to front view, go to general, go to support, create a fixed support. And this support I'm going to assign only here and here. Okay, to all these nodes over here. So you can see in the isometric view and assigning to that nodes. Okay, so we can assign here also, but not needed. We will continue with this and we will see the analysis. And I will go to property. Okay, I will consider the very least section, cross section, so that it will get fail na. So accordingly, like we will see steel design. So I just clicked the section database where we are going to select some least section. Okay, so here I will continue with the same American cross section, W in the sense I sections. Na? So here it was a bigger size. So I will go to the small size. Definitely it will get fail. That's why I'm going to select this, add. So this I section I'm going to assign to the whole view. Okay, now you can see in the 3D rendering how it looks. So it was a very least cross section and you can see. Okay, and I'm going to put a huge load. We will see how it works. Okay, now I'm going for loads and definition, load case detail, add, and I'm going for a date load, and I am going for a live load. Okay, and I'm going to put a date load self weight in y direction, assigned to the whole view as usual, since it is self weight. Live load, I will consider uniform distributed load or nodal loads. I will consider nodal load also. In Y, I will put minus 15 or minus 18 kilonewton. Okay, and then member load, uniform force of minus 12 kilonewton. Okay, add. Okay. Okay, this where I am going to put means like I will consider only this top nodes. So this one you need to select the nodes now. So select the node cursor and then select the nodes and then assign to selected nodes. Okay, we got it. And if you want to reduce the size now, see when you are putting like this is auto save option now. It is coming. Okay, so here you can go to symbols and labels. So click this icon and where you can go here scales and you can put apply immediately and this is point force na you can just try to put like this and you can see it's getting reduced. Okay, and then apply. Okay, so that we can change the scale also accordingly. Okay, now I will put the uniform distributed load for the member. So you need to select the beam cursor and okay, what I will do means I will select this and also so this slanted beams also. Okay, and also this beams. Okay, we will see how. Not vertical beam. I selected all other beams. Okay, then assign to selected beam. Okay, this is how like we have. Okay, now we have nodal load and also uniform distributed load for members. Okay, we can have whatever loads, but now I'm considering this loads. So 18 also heavy, 12 also heavy, not that much heavy since it is like a big span. So for that, like we will see how it works. Now what I will do means like as usual, I will go for all and then I will run analysis. So we should get zero error and better if we are getting zero warning also. See, we are getting zero error, zero warning, zero note. Okay, now we can stay in modeling mode. Okay, now we can go for design since we are not getting any errors. Okay, okay. So if you are going for post processing, now click OK and you can see the node and also displacement reactions, right? Okay, but we can go to beam and we can see forces and stresses and graphs. So see for each and every beam, we can see the graph also here. This is for shear force and bending moment graphs. Okay. For example, if you're selecting this, you can see the MZ values, FY values, FX values and all. But here we don't have any. But here you can see the things. And what about the slanted thing? See, accordingly you can see the things. This is for live load, and you can also see the dead load. And if you have load combination for that also, you can see the graphs. Okay, but we don't have any other option here. Okay, but we will go for steel design. Then we will get some option. But before steel design, like we will also have a load combination. So you know, right? Before I told you how to create load combination, go to loads and definition and click this and add, and you can go here define combination if you want manual combination or auto load combination based on the regional codes, ACI code, British code, Indian code and all. Okay, I will go with ACA and I will go for table. For example, like if you want more details, you can refer the particular code book for table 1 or table 2 like that. I will go with table 2, generate loads, and you can see here. So it is considering some combination. You know, like it is asking, we have changed something now, so that we need to go for again, analysis. So everything will change now. That's why I put yes. Okay, these things we can able to modify also. I told you now. So this one, if you want to change the factors, you can change accordingly. Here it will get changed. Okay. If I am changing this to 1.5 7, then you can put change. You can see it is getting changed. Now you can see it is showing C symbol because we have changed it. Okay. Like this, we can also modify the factors in the auto load combinations also. Okay. Okay. Now I will analyze again so that we will see based on the load combination also we are getting or not. Definitely we will get because before itself we are not getting any error. Okay, accordingly, we can go to post processing where everything it will come. You can see, and I will select the second because where both considered with the combination. Now I can go for beam and then graphs. Okay, and you can see the values for it. Okay, so the stresses in the sense like you can see, we take an I section. That's why here it is coming with I section. Whatever you selected, that particular beam it's showing here. Okay, you can also see you can put some distance. See at 7.22 meter, these are all the values. This is like a stresses, and you can also see here the value. See, it is like starting from this much, and then maximum this number. So that red is like more having more stress. Okay, on that particular point. Okay, I will go back to modeling. These are all the things before steel design post processing. But now what I'm going to do means like I will go for design. Okay, and here I will go with the steel design and I will go with the default AISC 36010. And as usual, we need to define parameter, but we have many parameters to define so that we can select any of this. Okay, so select parameter first. So you just put everything this way and then whatever you want, you can put back here. Okay. I will consider this FUFI. This is very important for steel design. Okay, and then we can also consider the ratio. Okay, and I will click OK. Okay, I will define the parameter. So as usual, 415 grade of steel, add yield steel. I will consider 250 grade of steel. Okay, and ratio by default it will be 1. Okay, so I can put add directly. If you're not putting also, it will take 1. But if you want to reduce that, we can reduce also. I mean, I will put assign to view because everything is a steel structure. This is like if you're not assigning also, it will take 1 utility ratio. It is okay. Okay. Now I will go for commands. Okay. When I'm going for command, like now I will put only member takeoff. Okay. Nothing more than that. I'm going to put assign to the view and we will see whether we are getting steel design or not. Analyze. Okay, since we are not putting any select options and all, that's why the iterations was not happen. I will go to view output file. See, you can see the steel takeoff. But this is getting pass or fail, we will see. This is just showing only the takeoff, but it is not checking whether it is getting pass or fail. Control F, and then I can put fail because nothing there. So accordingly, you need to put the commands. So it is not showing pass or fail. I will select here. See here also steel design not happened. Okay, and I will go to post processing. Now I can go to beams and there is something called utility check. This is what like we are getting after steel design. See utility check, it is not showing anything. Okay, because we need to put commands accordingly. Then only here it will be success. So still doesn't was not success, but utility check is coming because we put a takeoff command. Okay, now what I will do means like I will go back to design. Okay, I can remove this. Okay, how? Right click and then delete command, or you can just yeah, here the parameters we have, that is okay, and I will go for commands now. Okay, but here we have check code, fixed group and all now, so we need to create group first. So otherwise what it will happen, like I will tell you. So now I am going for check code alone. So check code and then I am going for a member takeoff. Assign to the view. Assign to the view. Then only it will check whether getting passed or failed. That's why check code. Now we will see analyze. Okay. Now we got output file. Okay. Now you can see steel design. Can you see? Because we are putting check code, na, that's why it is checking whether it is getting passed or not. I know, we know, right? Like we gave only like least cross section so that it will get fail everywhere. So whatever getting fail, for that we have a still takeoff. So this is not acceptable since the members getting failed. We can't like proceed further. Okay, so but we will see the utility ratio in post processing. See, go to beam and then utility check. See,
Sir, 1 second.
yeah,
Sir, can I, sir, you said no, whatever getting fail, that only this steel takeoff is showing.
yeah.
I mean, for example, if we have 10 elements, only 5 of them is failing, and only for the 5 element, the steel takeoff they will show. Is it like
No,
that?
no, no, no. I mean, like whatever the comments we are providing, accordingly we are getting the results. Because I am not putting any select optimization, na. So once you are putting select optimization, and then there is another takeoff. So that takeoff only acceptable. Now I am just continuing only with the check code. So everything is getting filed. Why? Because like everyone's actual ratio more than one. We put allowable ratio one, right? See here you can see 49, 92.7. So everything is getting failed. Wherever you can see red color, which means like all
Mm.
getting failed. So it's supposed to be less than one. No one is like less than one. So all members failed because very least section W4 plus 13. So allowable ratio is only
Okay.
one.
Okay. So if it was if we have defined select optimization, automatically the
Ah,
STAAD will tell us you can use the other
yeah,
section like that,
yeah,
correct?
other section. Yeah, so that I will go for modeling. Now we can see no single member getting passed because we put more live loads. Like that's why. Okay. Even we can go with
Okay.
the dead load. Even for dead load also, it's not getting passed. Okay. I will go to modeling. What I will do means like now I will go back to design and here we can see other commands. See, I am putting only check code and then member takeoff, nothing more than that. And here also we have takeoff. That takeoff only we can consider because after select and select optimization, we are having the takeoff. Okay. See here it is asking for group something. So why can't like we can have groups, then we can go here. Okay, so control G is the shortcut. So I will go for C. Why I am going for group means like this lowest members, it should be like the same cross section. Otherwise like I can show you this way. First I will go with commands. I will go for select, and I can go for add, and then I can go for takeoff. Okay, now we are not having any groups. We will see assign to view and then takeoff. Now I will analyze. So I am doing this thing separately so that you will get confident with commands. So we can play with the commands. Whatever commands you are providing, accordingly the stat pro analysis will be taken. Like that's why. Since we put select now, so that it will take some time. It will look for feasible options, feasible cross sections. Okay, we have only one warning, so we can see the output file now. And the warning also we will consider. So some member sizes have changed. This is not that much issue because before it was only one size now. Now like member sizes have been changed, right? That's why it's showing some warning. Some member sizes have changed since last analysis. That's not an issue. And we will see. This is what are the member we are providing. Okay, this is what we provided. Okay, and we will get the design members. Okay, this member, what we can say, like user provided member, and design member, we can see it's getting passed, and you can see the sizes also it's getting varied, and you can see the takeoff. So this is what like you should consider. But again also you should check the utility ratios and all. Okay, now you can see here the takeoff of 95 kilonewton only. So that's why it is not withstanding the loads. And here you can see 557.81. So the software itself like analyzing and then giving us the solution. Okay. So this member, now you can see here, it will come. So the member, this is W1258, but here it is different. W1258, but what about here? See, W1253. See, no members, if it is like in the same, it's supposed to have a same cross section, but here having different cross section. So what we can do, there is one solution. That's why we need to go for a grouping. Okay, so all these lower members should take the biggest cross section. Okay, like that. Okay, so you can see the post processing and utility check first. See, now you can see everywhere it is getting green. I told you now if it is green color and less than one, it's getting passed. You can see the sizes here. Not W. See, this is like what we provided, and this is what the software suggesting. This is user defined profile, and this is like a design profile. User profile, design profile we can consider. So user profile getting a fail, and design profile like it's taken based on the provided loads. And since we gave allowable ratio na, so that's why. See, what if we are providing like for safety concern, like I will go for design again, I can edit parameter for a ratio. I can edit this edit command, right click edit command, I can put only 0.9. So it's even more good assign. So we assigned directly since everything is selected. Now I will analyze. Because by default itself, one it will come if you're not providing the parameter. Since we provided the parameter, that's why I changed to 0.9. So 0.9 is good, even more safety, even more it's safer for the structure. So that the software will check everything below zero point 0.9. So it will not consider 0.91, 0.95, 0.99 and all. So that I will show in the utility check in the post processing. Okay. Now also you can see the output file. Maybe some changes in the takeoff. See, now you can see since I'm changing some parameter, now accordingly here also it's changed. And here also you can see like members also changed. Because accordingly you are getting passed now, that's why.
Why is that weight they're showing in KN?
Kilonewton. Yeah, the steels and reinforcements in kilonewton only, right? Ton, metric ton, kilonewton.
Okay. So like we can change it, right? The
We can
weight.
change that one. Yeah, to any other tons or metric tons. I'm telling since we changed some parameter, now accordingly you can see the kilonewtons also getting changed. Okay, click OK. Now I can go to post processing and go to beam and then utility check. And you can see here it is just taking 0.9, and whatever it is just it's even more safer for our structure. So that's why I put that parameter. If you're not putting that parameter also, it will be one only. If you're putting, you can put a lesser value. But if you're putting more lesser value, then it is not economical. You need to consider the economic things also. So then the structure will be more costlier if you're reducing this kind of things. So you can go with 0.9. It's good. Okay. Okay. But you can see here, this is
Sir,
W.
sir, this utility ratio means actually the provided strength pi required or required by provided. Oh, I
Uh,
mean, uh, what actually it is checking? This utility ratio.
no, like see, we are providing some loads, right? So accordingly, for that load, whether the member is getting pass or fail, it's showing. Okay. So it's a ratio. Like if you want to consider, like you can go to the particular code book, whatever we are putting na that code book, and we can refer. There might be we are provided with some formulas. So ratio in the sense it will try to calculate the load with the self weight, something like that. Like it should not like more than 0.9, so that anything below that, like it's getting passed. That's why here everywhere we are getting green color, and you can see the values less than 0.9. Okay, you got right point.
Okay.
Okay. Okay, now here it is W1258, and here W1258, here W1258, here W1461. So everything in the same line, it should not have different members. There comes grouping. Okay, and here also you can see something W4 like that. And when you click here, it is W12 like that. So that what we can do means, like I will go to modeling again. Okay, I'm going to put group now. Okay, for group, what we can do, I can just select the whole bottom, and I can go for Control G. Okay, I can put the G1, and this is something beam, and click OK. And you need to associate to selected geometry because beam unassigned. Associate. Okay, now close it so that go to front view. Again, I'm just selecting this as one group. Here also we can go with vertical separate. Otherwise, like we can continue with the Control G, and I can go for G2, and this is also beam. Click OK and associate to selected geometry and close it. Again, I can consider this as separate. So see in the isometric view, Control G and create G3 beam. Click OK. Associate to selected geometry and close. Everything is assigned. It should be like this. We have G1, G2, G3. Okay. Now I will go to design. So here what we have is like important. So there is something called fixed group. Okay, I can just go for whatever we consider the group that it will consider also. I will add, and then group. So in the group, this is what important. So to get the similar members. So you can see the property specification, cross section area AX, and then we can consider this is like SY SZ. We can consider this is shear modulus, something like that. Okay, so I will section modulus something. We have a cross sectional area for the section, and then section modulus. Okay, and I will consider, we can consider the cross sectional area base or section modulus. Okay, it's better if you're continuing with the section modulus. Otherwise it will continue with, it will select the biggest cross section. I will go with the section modulus. And if you want to consider some similar beam, then we can consider the available beams, but it is not good. Now I will go only with the SCZ, and I'm going to add it. Now I can, okay, now we added something like this, right? Okay. So that we need to arrange it though, so we can see section fixed group, it is coming. Okay. And this also, we need to go for three, okay, because we have three groups. three group na, so that again I can go to SCZ add. Again I will add. So totally three times we are adding. So that separately it will come. And go here, select only this group. Okay. And you can check here, assign to the selected beams. Again SCZ, and we can select based on the group also. G2, right? Okay. And assign to selected beam. Okay. And here again G3, it will select. See G3 alone because both selected, and assign to selected beam. Okay, this I taken from select. Okay, okay. Now we can see separately this one, and then this one, and then this one. Okay, okay, okay. But we can change the arrangement. STAAD editor. And SCZ and all, like here we have, right, the parameter S is a fixed group and all. Okay, so I'm totally taking okay, I will consider from this parameter until here. I can put control X. Okay, what I'm going to do means like I will put before this one, or here I will put. Otherwise, like we will see how it is working. I'm not going to change it. Okay, okay, we will see anyway. It may come correctly. Okay, I will analyze now. If not coming, we can arrange it so that we will get the results what we are expecting. Okay, we are getting only one warning. Okay, we can go to view output file. Now I can go to, this is like the failed one, so no problem. Now I can see here, and here you can see, so everywhere getting passed, and you can see only one takeoff. Okay, but maybe it's not considering what we are thinking. Okay, see, which means like you can go to post browsing, that is common, the same utility check and all. Okay, but here W461. See, you can see W461 everywhere. See, now it's getting success. This is what I am telling now. So everywhere this bottom should have a same sizes. So this is also because we are putting everything in one group. Do you understand the concept? Like here everywhere getting same size. And this one W4 159, and this one also W4 14 159, because this is under one group. And again in the top W4 145, and again this is W4 145. Okay, it's getting success. No need to change anything. Now you got the point. Nah, this is what correct. Now, if you are okay with the utility check, then go to results and update property. Then only it will get update. Otherwise, like here in modeling, see modeling, like when you right click, it will be having the least size, the failed member. To update the success member, you need to go here, and you can also see here general. See many things coming na. So nothing is assigned. See everything only this failed member. So you need to go to post processing, go to results and update property. Yes. Now operation completed successfully. This is good. Okay, now you can see the modeling and you can go to geometry or general. See now you can see only the W14 cross 61. So like this. See, now we are getting correct. So now you can see the 3D rendering. This is how the steel design work. So whatever the member getting passed, you can update from the post processing. It will update directly. See, now you can see the biggest cross section. So now you are okay with the steel design, right? This is little complex if you're not okay with the basics. If you're okay with basics, then everything is easily coming. So the meeting also going to end in few seconds. Now, are you okay with the steel design like the way I did today? So this is how you should do the steel design.
Okay, sir.
Okay. So the order is important. If you're changing the order, you will not get this kind of result. You will end up with something, maybe more errors. So do you want to join after 10 minutes? Now it's going to end. Hello?
Hello.
Ah, okay. So all of you there, right?
Yes.
Okay. So here, like we are getting many cross sections, right? Why? Because like when we are not putting group na before the software considering some other things also na. That's why. Now after updating the things, like you can delete this unnecessary things also. But no problem. Anyway, we updated na. That's why we can also see the things here. So this one is there, and then this one is there. This two W4 cross 61, W14 cross 169, and then this one W14 cross 145. Okay, okay. So this one, like you should update after checking the utility check and all from post processing. Okay. So no need to analysis again. So since we analyzed and then after based on the analysis only, like we updated the property, like no need to analyze. Like yeah, maybe I was thinking whether to delete everything and to analyze back. So no need na. So practically we have done the steel design. So that I will stop share.